0. Now, what's common between these terms here is v of x plus h, and it's on the right-hand side of the products, okay? So what we're left with over here is we're going to be left with, let's say, we're going to be left with u of x plus h and minus u of x, which needs to be multiplied by v of x plus h. You can actually see that when we multiply with the brackets, u of x plus h times v of x plus h gives us this, minus u of x times v of x plus h gives us this. And then what we have, it's plus, and the commonality here is u of x, so it's u of x times, well, what's common here is, so we take out the commonality, what we're left with is v of x plus h minus v of x. You can probably see this coming into shape here now. This is all now divided by, h. Okay, so this is all divided by h. Now, what we could do now is this, is that we can actually, there's a common h here across both of these terms, the common denominator, so we can split this up. So therefore we have dy dx. dy dx is equal to the limit as h tends to 0. Okay, it's the limit of this piece divided by h, so it's u of x plus h minus u of x times v of x plus h, all divided by h, plus the limit of a plus b when they're differentiable is the same as the limit of a plus the limit of b. So this now becomes the limit as h tends to 0 of this thing here, which is, let's say, it's u of x times v of x plus h minus v of x, okay, all over h. Now, if this was just a normal function, what we could start doing is we could start dividing in by the h, okay? And what we're arguing here is what we're going to do is we're going to associate this h with this particular left term here, so that there's, excuse me, we're going to associate the h here with this particular left term. We're going to differentiate this particular bit here as h tends to 0. So this now becomes, therefore we have dy dx is equal to, this becomes the limit of u of x plus h minus u of x all over h as h tends to 0 times, these are differentiable functions, times the limit of v of x plus h all over h. Sorry, excuse me. So we're just differentiating here. We're bringing the h. The h is going to be associated with this particular part of the term here. So now we're just getting the limit of v of x plus h as h tends to 0. Plus, same thing over here. The infinitesimal is going to be associated with this. We're going to change this over here. So this becomes the limit of u of x as h tends to 0 times the limit of, excuse me, of v of x plus h minus v of x all over h, okay, as h tends to 0. And what hopefully we can see here is that from our definition of the limit, don't forget, recall that the limit of a function, or the derivative of y with respect to x, is simply equal to the limit of f of x plus h minus f of x all over h as h tends to 0. That's a definition. That's a definition of a derivative. So what we actually have here is we have the same thing here for this function u. Okay, so effectively this is the derivative of u. So this becomes, therefore we have dy dx is equal to this particular limit here, this part here. Let's just box that off. This is the derivative of u, by definition of u, with respect to x. So this becomes du dx times. And what we have over here is we have the limit of this particular function here, v of x as h tends to 0. Well, h is tending to 0, so this function here is actually going to end up as just v, function v of x, okay, plus what we end up over here is, once again, in this particular situation here, we don't have any h's associated with this. So this is the h is 10 to 0 has no effect in here. So this actually just becomes u of x. So this becomes the function u times, once again, here we have our definition. Here we have our definition of a limit. So this is the limit of uh, v of x plus h minus v of x, or the definition of a derivative, which is the limit of v of x plus h minus v of x all over h as h tends to 0. So this is the derivative of v. So this is effectively dv. This is dv dx. And so what we've now arrived at, okay, is the derivative, of a product of two functions where the functions are both differentiable, okay, is actually equal to the derivative of the first function times the second function plus the first function times the derivative of the second function, which is exactly what we wanted to show. We wanted to show that, just going back here, okay, we wanted to show that if f of x is equal to u of x times v of x, well then the derivative of y, the derivative of f with respect to x is actually equal to du dx times v plus u times dv dx, which is effectively what we have shown here. So guys, once again, this is Jonathan Lambert with Maths and Stats, and I hope that this video was in some way intuitive, and more importantly, I hope that was helpful for you, and thanks for watching. Okay, bye-bye.